So much for nice introduction. So I would like to thank the management and the organizers of MBC and also the Pencil Bits Private Limited. So I would like to take this opportunity to deliver a guest lecture on uh, unsupervised learning in machine learning. Okay, particularly we are going to cover unsupervised learning of machine learning techniques. So this session is for 2 hours. Then again, afternoon we will have 1.5 hours. So in this session, we are going to cover the various unsupervised learning algorithms of machine learning, such as like clustering and association, and also we are going to discuss about ensemble machine learning methods, and also we are going to discuss how that clustering techniques is going to be evaluated. That is, the performance of the clustering techniques is how it is going to be evaluated. So we are going to discuss all those things. Shall I start, ma'am? Whether some more people need to join, let me know that.
We can start. It is already 10:40.
What, ma'am?
We can start. We can start the session, sir.
Okay. Okay. Thank you. Can you able to see my screen, everyone? Is it visible to you?
Yes.
Okay. Thank you so much. Yeah, so we are going to discuss about unsupervised learning in machine learning. Here, this is the overview of the topics we are going to discuss in the today's session. So first, we are going to briefly have a recall about machine learning and its types, and machine learning process flow, ensemble machine learning algorithms, in which we are going to cover backing, boosting, and voting. Then we are going to discuss about the different clustering methods. And here we are going to discuss what is clustering and what are the different categories of clustering. Then after that, in clustering method, we are going to use similarity measures, that is distance calculation. Particularly, we can name it as distance calculation. So we are going to cover about that. What are the different similarity measures that are followed in clustering techniques? Then we are going to discuss three clustering algorithm particularly. One is k-means clustering, another one is hierarchical clustering, another one is density-based clustering, and also we are going to discuss about EM, that is expectation maximization for soft clustering. So these are the topics. So the participants can interrupt me at any time if you have any clarification. You can ask your clarification. You can discuss with me if possible. Make this interaction, make this session as interactive session. Okay, I'm expecting that one. So first, let's start about the machine learning. Even though you might have discussed about this machine learning and its types in the previous days sessions, we are going to like just recall about that machine learning. So we all know that. So the artificial intelligence is currently ruling the world. So the machine learning algorithm is the backbone of artificial intelligence. So most of the industries, most of the organizations, even the government sectors also are using the machine learning algorithms and artificial intelligence techniques in order to automate most of the task. Okay, in all the applications of the industries, the artificial intelligence are being used. Even in lot of applications are using AI technologies. So because of that, we can easily analyze the data, we can easily recognize the patterns, and also we can make the predictions without doing the explicit programming. We can do those things. So machine learning will have lot of mathematical models. So because of those mathematical models, the machine learning will be used to enable the computers to learn the insights from the data. Okay, there are a lot of hidden patterns from the data. So from the data, so the hidden patterns will be learned by the computer with the help of machine learning algorithms. So particularly if you take the machine learning algorithms, we are not doing the programming for machine learning techniques. It may be a supervised learning or it may be unsupervised learning. We are not doing the programming, or we are not writing the code for the machine learning algorithms. It may be a simple linear regression or multiple linear regression, or it may be a classification problem like naive-Bayes classification or decision tree or random forest. There are a lot of supervised learning algorithms are available. For all those learning algorithms, we are not doing the programming part, but those algorithms will be learning from the data. So here, particularly if you take the, for example, supervised learning, we are having data with the sample outcome also. So from that, it will try to identify some insights from the data. So based on that, like some decisions or some predictions can be taken. Yeah. So here there are three types of machine learning techniques. One is supervised learning, another one is unsupervised learning, another one is reinforcement learning. Reinforcement learning is also a part of machine learning. Supervised learning is nothing but the training data will include the desired output. We will have input data and also we will have the respective outcome of each record for each data point. So based on that, algorithm will learn something. So that is called as supervised learning. So data will not have desired output. Okay, so it will have only the input data. So the input data will have some similarities. Input data will have some insights. So from that particular similarities, the unsupervised learning will learn the hidden pattern and it will perform, or it can be used for certain operations. So that is unsupervised learning. And reinforcement learning will learn from rewards and penalties. So it is a dynamic environment. In the dynamic environment, for every action, it will receive either penalty or reward. So based on the penalty or reward, then it will improvise itself in every action, in every iteration. It will improvise, it will improve itself. That algorithm will learn itself. So based on that, the decision will be taken. So that is called as reinforcement learning algorithm. So this is a fundamental process flow of machine learning techniques. So in the machine learning algorithms or in the machine learning concepts, there are two phases. One is the training phase, another one is the testing phase. In the training phase, the learning algorithm will learn from the training data. So whenever we have a data set, from the data set, the training, that is the algorithm will learn from that particular data set. So that is called as training data. So during the training phase, so the algorithm will try to identify or will try to extract the hidden information from the particular data. So based on historical data, it will learn something. So that algorithm will be trained. So that phase is called as what? Training phase. So from the training phase, we can able to generate a model. So now the model is trained, the model is learned. So after that, whenever we provide a new data, so the new data will be like assessed by that particular model and it will make some prediction, okay, regarding that particular data. So that is called as what? Uh, Testing process. In the testing process, the new data or the real-time data or the present data can be given to that algorithm. So based on that training, which is learned, or based on the information which is learned from that training phase, the model or the machine learning model will perform certain operations with respect to the present or new data. So that phase is called as what? Testing phase. Then next one is supervised learning algorithm. So as I said already, in the supervised learning algorithm, it will learn from the example data, and every example data will be associated with the target response, and the target response can be a numerical value or it can be string label such as classes and tags. So with this particular target label and with this particular string label, so it can able to predict the correct response whenever we give the new examples. Okay, so that is the concept of supervised learning. So this approach is similar to like a scenario like human learning under the supervision of a teacher. So for example, whenever we learn something from a teacher, the teacher will give input and also the teacher will give respective output. So based on that, we will learn something. So that is called as what? Supervised learning. Under the supervision of something, then algorithm will learn that. So that is called as supervised learning. So here, yeah, we are having that input variable X and output variable Y. Okay, we have both variable, but the mapping function has to be learned from the particular input data. So Y has to be, that is X has to be mapped to Y. So for example, whenever we have an input like 5 and output like, for example, 20. So how that 5 can be mapped to, like, for example, 20. Okay, so that has to be identified. That is called as what? Mapping function. Maybe 5 has to be multiplied with 4, or 5 has to be, 5 can be used to divide, for example, 100. So like that, it may be anything. The mapping function can be anything. So the mapping function will be learned by that algorithm and it will perform the operations whenever the new data is coming. Okay, so that is called as mapping function. So the supervised learning algorithm will have the input variables and also will have the output variable. And during the training phase, that supervised learning algorithm will identify the mapping function. So that will map the respective input to the output. So in the supervised learning algorithm, we all know that we are having the two major techniques. One is the regression, another one is classification. We all know about the regression. We are having simple linear regression and also multiple linear regression. So with the help of that, you can able to predict something. If you want to have some output variable as a real value like rupees or height or house rent or like or if you want to predict the number of patients, that may be number of patients suffered by COVID. So like that, if you want to have that such kind of situations, then you can use this one. Please wait. Yeah, a small disturbance. Am I audible now? Can you hear me?
Yes, sir.
Okay, thank you. Yeah. So in the supervised learning, we are having the two major tasks. One is regression, another one is classification. Regression means we all know that. So based on the input, we have to predict some output. So for example, when we have historical data about COVID, then we can able to predict something, number of people that will be suffered by COVID. So based on the historical information, we can do it. If you want to predict some real value, then we can go for regression. And if you want to predict some like the two possibilities, it is kind of a classification like yes or no and one or zero. So like whether the patient is whether a person is having heart disease or not, or whether the plant is having this kind of disease or not. So if you want to classify only limited number of classes, either 2 or 3, spam or not spam. So like that, if you want to have such kind of classification, then you can go for the classification algorithm. So in the regression, you might have studied like simple linear regression and multiple linear regression like that. In the classification, we are having logistic regression. Logistic regression also can be used for classification. It is based on probability value. And naive-Bayes classification algorithm, decision tree classification algorithm, support vector machine, random forest algorithm. So like that, n number of classifications algorithms are available. And those, that is regression classification, will be coming under the category of supervised learning. The next one is unsupervised learning. So as I said already, in the unsupervised learning, the training data will not have the respective outcome. So for example, it will have a lot of attributes in the input data. So from the input data, the algorithm will learn themselves to discover interesting structures in the data. So no one will guide. So there is no outcome variable. So that it cannot be, that is, there is algorithm cannot be guided by that particular outcome variable. So that algorithm itself has to identify from the only the input variables. So what is behind that particular data, what is the hidden pattern from the particular data. So that has to be identified by that algorithm. So mathematically, the unsupervised learning algorithm will have only the input data. There will be no corresponding output variable. And this unsupervised learning can be mainly used for anomalies, for detecting the anomalies and outliers such as fraud and defective equipment, and to group the customers based on the behaviors, particularly for the sales purpose. Suppose if you want to perform certain operations like this, then we can go for the unsupervised learning. For example, a simple example I can give. We are collecting the ages of people. Okay, assume that we are having an application. In that application, we are uh, we are getting the ages from that particular person. So the people will be giving that age value. So instead of giving 80, the people may give one more zero in that. So automatically what will happen? The age value will become 800. There is no possibility of age like that. Okay, so that is referred as what? Error data, or that can be referred as what? Outlier. If you want to deduct, so if the number of values are very less, human itself can able to identify that kind of error. If the number of records are huge, suppose if you have 10,000 records, if you have 1 lakh records, if you want to deduct that error age, it is very, very difficult by the human. So that we have to use the machine learning algorithm, particularly this unsupervised learning algorithm, to detect such kind of outliers. 800. Instead of giving 70, the people may have people may give by mistake can the particular person can give 700 or minus 70, or only 7. In some situations 7 also not possible. For example, in a particular, it is with respect to the application. With respect to application, it may be changed. So if you want to detect such kind of error, or such kind of anomalies, or such kind of some fraud transaction. Okay, so if there is such scenario, if you want to detect it, then we can go for this unsupervised learning. Okay, so here so in the unsupervised learning, when learning data contains only some predictions without any descriptions or labels, so that the algorithm itself has to find the structure of underlying data and discover the hidden patterns, or determine how to describe the data. So this is called as what? Unlabeled data. If the learning algorithm, or if the machine learning algorithm learns from unlabeled data, then it is referred as unsupervised learning. So in the today's session, we are going to discuss about this unsupervised learning techniques. Yeah, so here in the unsupervised learning, again, we are having the two tasks. One is association and one is clustering. So association, so this is an association rule learning algorithm or problem. where if you want to discover the rules that describe large portions of your data. So for example, people that buy X also will buy Y. So for example, if you want to, for example, whenever we have certain products, if people buying this product, then the particular people will buy the another product. Okay, so now the two products are associated with each other. So that kind of scenario, if you want to identify that kind of pattern, so that is called as what? Association. Whenever the people buy bread, they can comes also. Whenever the people uh, uh, buys shoes, then automatically the people will buy socks, like that. So similar to that, whenever the people buy pant, then the people will buy shirt. So like that. So we are identifying some associated, that is associated patterns between that, like attributes. So based on that, we will identifying that hidden patterns. So that is called as what? Association. Next one is clustering. In the clustering, we are going to identify the patterns by grouping the data. Okay, we are going to group the data, and based on that, we are going to predict, or we are going to understand or interpret some informations by grouping the data. So that is called as what? Clustering. So for example, grouping the customers by purchasing behavior. Okay, based on the purchasing behavior, if you group the customers, so that is called as what? Clustering. The next one is reinforcement learning. So here the program will interact with the dynamic environment. So here every action will be evaluated by the dynamic environment. If that action is good, the reward will be given to that particular agent. If the action is bad, then the penalty will be given, that so that whether the reward is given, so that the agent will think that okay, we have done the correct action. So from that it will learn, and also when the penalty also given, so we have done the wrong action. When the same output is coming in the next sample, then automatically that kind of action should not be taken. So like that, in every action, that agent will learn something. So that is called as what? Reinforcement learning. So here the program is provided with feedback. So the feedback is either penalty or reward, so that it will able to learn itself in the dynamic environment, so that it will improvise itself over a period of time. Okay, so that's reinforcement learning. So this reinforcement learning algorithm will be used in most of the dynamic scenario. So these are the summary of machine learning models. So here, under the supervised learning, we are having regression and classification. In regression, we are having linear regression. In linear regression, we are having simple linear regression and multiple linear regression. Under the classification, we are having number of techniques like logistic regression, naive-Bayes classification, decision tree, random forest, support vector machine, KNN. So these are the some of the classification algorithm. And under the unsupervised learning, we are having two categories. One is clustering, another one is association. Under the clustering, we are going to have three major algorithms. One is k-means clustering, then agglomerative clustering, then DB scan clustering. Under the association, we are having association rule mining. So this is a summary about machine learning models. So if you have any clarification as of now, you can ask me. I give you a minute for questions. If you have any questions, you can ask me now. Yes, sir. Unsupervised learning is only for non-labeled data, particularly for non-labeled data. Even if you have questions, you can post in chat box also. Yes, sir. I am having examples with the data set. So as per the syllabus, what uh, have been given to me, I have some data set and also some the problem that is solved example with that particular data set. I will explain that also. So here we are going to have three major clustering algorithms. One is k-means clustering algorithm. Another one is agglomerative clustering algorithm. Another one is DB scan clustering algorithm. There are a number of clustering concepts are there, clustering techniques are there. So one is partitioning method, partitioning clustering. That so for the partitioning clustering, we are having k-means clustering. Another one is hierarchical clustering. So for the hierarchical clustering, we will have like agglomerative clustering. Another one is density-based clustering. So for the density-based clustering, we will have DB scan algorithm. So these are the three algorithms for each type of clustering. For all these three algorithms, I'm having a sample data set and also the solved example. I'm going to explain with that. If any other question, please feel free to interact with me. Okay, thank you. Now let's proceed with the ensemble machine learning algorithms. So uh, I have prepared this presentation with respect to your syllabus. So you have given one syllabus. So based on the syllabus, I have prepared this presentation. So in which the first one is ensemble machine learning algorithms, in which we are going to use three techniques: backing, boosting, and voting. One more technique also there, that is called as stacking. Since the stacking technique is not in the syllabus, I'm not including that. So that we are having only three techniques: backing, boosting, and then voting. So first, let's understand about what is ensemble learning. So here we know that there are number of machine learning models out there. For example, if you take classification, we are having like Naive algorithm, decision tree algorithm, and also like a support vector machine algorithm, random forest algorithm. So like that number of techniques are there. So here we all know that the classification algorithm will be evaluated based on the accuracy. How a classification algorithm is classifying the samples. Okay, whether that samples are being classified correctly or with more accurate or not. Okay, so that is the purpose of classification algorithm. So here, in some situations, every algorithm may give some different classification for some data. Okay, whenever we have some data point or whenever we have some records, for some record, the decision tree will give one class and random forest may give another class. And for example, like support vector machine may give another class. So that here, the purpose of this ensemble machine learning algorithm is we are going to combine multiple individual models. Because of combining multiple individual models, we can be able to create a stronger and more accurate predictive model. Okay, so that is without that is by implementing only one model, we will not take decision. By implementing multiple model on the same data set or with different data set, then we will generate a stronger and more accurate predictive model. So that's a concept behind the ensemble machine learning model. So in the ensemble learning, it will combine multiple individual models to create a stronger and more accurate predictive model. So in this ensemble learning, it will leverage the diverse strengths of different models, such as like classification algorithm, or it may be like regression algorithm, in order to reduce the errors, enhance the performance, and increase the overall robustness of predictions. So it will lead to improved results across various tasks in machine learning and data analysis. So it will enhance the performance of machine learning models. So here multiple machine learning models are combined to obtain more accurate model. So this is a diagrammatic representation of ensample concept. So here we are having a data set. The data set is divided into multiple training set. Okay, we can have a simple data set, and that single data set will be divided into training set 1, training set 2, and training set n. So like that, a number of training set or subsets will be created, and the model will be learned from each training set, like model 1, model 2, model 3. So like that, we will take a subset of data set, and from that particular subset of data set, the model will be learning. Then we will have a combiner module. So that combiner module will integrate all the models which are learned from individual training set. Then finally, ensample prediction model will be created. So this is the concept of ensample machine learning. So here, for combining the model predictions into ensample predictions, we are having three techniques. Okay, we are following three methods for combining the predictions from different models. One is backing, another one is boosting, another one is voting. Backing means the multiple models will be created. All the models will be same type. For example, all the models will be the classification algorithm or the linear or regression algorithm, or it may be anything. So here in the backing techniques, multiple models will be combined together from different subsamples of the training data set. So here, what is differed? The training data set will be different. Okay, in the backing process, multiple models will be grouped together from different subsamples of the training data set. So the next one is boosting. In the boosting, multiple models will be generated typically from same data type, each of which learn to fix the prediction error of a prior model in the chain. So in the boosting process, so it will be learned from the prior model. In the prior model, if it generates any error, so that will be learned in the next level. Okay, for example, whenever we have a data set, the data set will be given to that model. If the model predicts the wrong outcome, then automatically, so that will be given more weightage in the next phase of learning. So that is the concept of boosting. The next one is voting. In the voting technique, or in the voting method, the multiple models will be combined together, typically of different types, and it will be used to combine predictions. Okay, so this is called as voting process. So here the it is this diagram shows the different ensample methods that are available in machine learning. Like for boosting, we are having gradient boosting machines, adaptive boosting, XGBoost, and light GBM, like that. Under the backing technique, we can have some random forest algorithm, and also for the stacking, we are having the blending technique. But in the syllabus, we will not cover stacking, and we are having the voting. Okay, voting technique will be adapted. So what are the reasons for using ensample techniques in machine learning algorithm? There are some reasons. Because of that, we are having ensample learning techniques in machine learning. The first one is it will improve the accuracy. Yes, of course, because of one model, if you make the predictions, the predictions may be wrong, the accuracy may be less. So to overcome that scenario, when we get information from, or when we get predictions from multiple model, so based on that, we can able to get the information, we can get that outcome. So if most of the models are giving some predictions, so based on that, we can take, or we can come to a conclusion. So that's why this ensample machine learning model will improve the accuracy. Then next one is it will reduce the overfitting. We will discuss about, so particularly we all know that the machine learning models will be suffered by the two problems, majorly two problems. One is overfitting, another one is underfitting. Okay, so we will discuss about the problem of overfitting and underfitting in the next slide very clearly. So the machine learning models will be suffered by overfitting problem, particularly in order to reduce that overfitting problem, then we can use this ensample models. And also, whenever you have only one machine learning model to predict something, there is possibility for high variance and bias. To overcome these issues, to handle variance and bias, we can able to get the result or get the predictions from multiple models, so that it will balance this variance error and bias error because of getting the predictions from multiple machine learning model. So since we are getting outcome from our predictions from multiple models, so that we can come to a strong conclusion with specific outcomes, so that it will improve or it will provide more robust predictions. Here, by pooling predictions, ensembles make models less sensitive to errors in any single model, leading to more stable and robust outputs. So first, let's start with backing. So the backing is also referred as bootstrap aggregating. So the another name of backing algorithm is bootstrap aggregating. It is mainly used for improving the accuracy and stability. So here the models will be, that is more than one model, that is multiple models will be trained with a different subset of data, with the different samples, with the different training samples, the models will be learned. So based on that, we will get more accuracy. Uh, we will get more accuracy in that machine learning model. So here there are different steps we supposed to follow. Okay, there are three steps should be followed. One is data sampling, another one is model training, another one is aggregation. So in the data sampling, we will have a large data set. Generally, we will have a large data set. So we will not give the entire data set to the algorithm to learn something from that particular data. Here, what we are doing, the data set will be divided into multiple subsets of the data. That is, the training data set will be divided into multiple subset. Then after that, every subset will be provided to the algorithm to learn. So here in the data sampling, multiple subsets will be created from the training data set using sampling technique. So the sampling means it can be random sampling with replacement. So using the techniques, we will create the subset of the training data set. The second step is model training. In the model training, training a separate model on which training a separate model on each subset of the data. Okay, because in the first step, we are dividing the multiple subsets. So for each subset, the model will be allowed to learn from that particular subset. Then the model will be trained. Then the third one is aggregation. Then after learning from that subset of data, all the models, all the predictions will be combined together. So from all the individuals models, then after that we can take either averaged for regression, or we can take majority voting for classification to produce the final output. Okay, so this is the aggregation. Final step is combining all the models, then we will come to a strong conclusion. Okay, so the conclusion may be the averaged, because in the regression technique we will have real values, so that we will take mean value. So the mean value can be more accurate, more close to the correct output. And also in the case of classification, we can have majority voting technique. So how many, based on the number of models which are producing the same result, okay, then we will come to the strong conclusion about that particular prediction, okay, or the particular class. So that is called as aggregation. So this is diagrammatic representation of backing technique. So the algorithms that use the backing technique is a random forest algorithm. We all know about it. You might have studied that. Random forest algorithm is a combination of multiple decision tree. Okay, decision tree will be used for classifying the data, whether yes or no, or like affected or not, or whether the particular person is having heart disease or not. The decision tree will be used. So if you believe in only one decision tree, that may not be more accurate one, so that we will construct multiple decision trees. So from that we will generate the random forest. So from that random forest, if a particular class is predicted by many number of decision trees, then that can be the final prediction of random forest algorithm. So random forest algorithm is a backing technique of decision trees algorithm. So based on that, we will like come to the conclusion. So here, as I said already, the training set will be divided into subset 1, subset 2, subset 3, subset 4, like that. A number of subsets will be created. And here, for example, the learner algorithm will learn from this particular subset. Then after that, every learner, every machine learning algorithm will generate a prediction. So finally, these predictions will be combined together. So that step is referred as what? Aggregation. Okay, that's why this since in the subset, in the dividing the subset, we are using the random sampling, and after that we are using the aggregation, so that it is referred as bootstrap aggregation. Then next one is benefits. What are the key benefits of backing technique? There are two benefits. One is it will reduce the variance and it will improve the accuracy. So in the first scenario, by averaging the multiple predictions, for example, if you take the regression technique, by averaging the multiple predictions, backing reduce the variance of the model and it will helps to prevent overfitting. So as I said already, there are two problems in the machine learning algorithm. One is overfitting and the underfitting. Overfitting means a model that is too complex or fits the training data too closely, but resulting in poor predictions on the new data. So for example, during the training phase, the model is learning too much. Okay, for example, it is completely learning from the data, too closely it is learning the data, but while giving the new data, if it predicts the wrong value, then this process is called as what? Overfitting. Particularly the overfit models will have high variance, meaning that they perform well on the training, but not on the new data. Okay, between the training and testing, there is more difference. So that is referred as what? Variance. To overcome this problem, if you reduce the overfitting problem, then automatically high variance can be reduced. Okay, variance can be reduced. So to reduce that variance, to avoid that overfitting problem, we can go for this backing technique, because we will take average of multiple predictions. Under is underfitting. Underfitting is in which a model is too simple and it cannot capture patterns in the training data, and also resulting in poor predictions on both training data and also new data. Okay, so in the overfitting, the model is too complex. It is generating accurate predictions during the training, but in the testing, it is not predicting correctly. Okay, so that is called as overfitting. But in the underfitting, the data set is not much enough to learn or to capture the patterns in the training period. Because of that lack of knowledge, because of lack of information gathering in the learning process, it will produce poor predictions on the new data also, as and also what? Training data. So this is called as what? Underfitting. So underfitting models will have high bias. Okay, underfitting models will have high bias. That is an error rate. So this is also can be reduced in backing. Another one is accuracy. Accuracy means by combining the multiple models, it leads to better performance than individual models. So you all know that when comparing with the decision tree, the random forest may produce a better result. Next one is voting. In voting, the multiple models are trained independently on the same data set. So here in the voting technique, what we are having, there are different models. Every model will be allowed to learn or train independently on the same data set. The data set will be same, but the multiple models will be trained. For example, if you take a classification algorithm, we will give you a same data set. We will allow naive-Bayes algorithm to learn from that. We will allow decision tree algorithm to learn from that. We will allow KNN algorithm to learn from that. We will allow SVM to learn from that. The data set is same, we will be providing multiple same models. All the models are the classification models. All the models will be trained independently. Then after that, whenever we give the new data, whenever the predictions is coming, then automatically every algorithm or every model will be providing some predictions. So finally, in the voting technique, we will combine all the predictions, and here we will apply the majority of voting. Okay, for example, if most of the algorithms are generating a particular class, only few algorithms are generating the another alternative class, means then based on the majority of the votes, then we will have the final outcome, or we will come to the conclusion. So that is called as voting technique. Okay, so here we are having two types of voting. One is hard voting, another one is soft voting. In the hard voting, in the classification task, the final ensemble prediction is determined by selecting the class that receives the most votes from the base model's predictions. So based on the majority of voting, it will be coming to the conclusion. In case of soft voting, so that will happen particularly in the regression task, the final prediction is typically obtained by averaging the predictions of the base model. This is also known as soft voting. So for example, train three models such as logistic regression, decision tree, random forest on a data set, and combine their predictions by hard voting. So the final predictions is based on the majority vote. Yeah, so here you can see the diagram. So we are having a same data set. Model will be different. Model 1, model 2, model 3. And here we are applying the voting techniques. So based on that voting techniques, we are coming to the final predictions. So in the voting, we will use the same data for different models. But in the backing, we are having same model, but a different data set. That is important. Okay, for example, we will have decision tree 1, decision tree 2, decision tree 3. But what will happen? So only that data set will be different. So based on that, the decision tree algorithm will learn. Then whenever we give the new data, so based on the learning, based on the experience, it is learned from that training phase. It will perform the action. Even if you want to see the code, you can have that like voting algorithm and all those things. So here we have to import the libraries in Python. Okay, we all know that the Python can be, there are a lot of predefined Python modules and libraries are available for implementing the machine learning algorithms. So here we are having the different Python libraries, particularly sklearn library, in which we are using SVM and also like decision tree, logistic regression, KNN, because this is the voting technique, so that multiple models will be trained, so that all the models are imported here. And here we are having the data set, and we are dividing the data set for training and also the testing. Here 70% for training data set and 25% for testing data set. Then after that, we are applying the different models. One is decision tree, KNN, and logistic regression. All the algorithms are being applied on the data set. Then we are coming to the final conclusion. Okay, so for all the algorithm, we are applying the voting classifier for applying the hard voting. Hard voting means based on that classification, majority voting will be applied. So for that, here the voting strategy is hard voting. So based on that, we will come to the conclusion. So this is a code, Python code for voting. So the advantages of voting: it is simple to implement and interpret. It can improve the accuracy by combining different models. It will work well when the base models are fairly strong and complementary. And these are the key differences between backing and voting on different aspects. So in the backing, as I said already, models will be trained on different subsets. Here the models will be trained on same data set. Here model diversity, typically use the same type of model. Example, decision tree means for all the subset, the decision tree will be applied. Here it will use different models for same data set. One is decision tree, another one can be SVM, another one can be logistic regression. So in the training process, it will use bootstrapping to generate diverse training data. So here no bootstrapping, the model will use the same full data. And here aggregation method, majority voting for classification, averaging for regression. Here also the same, majority voting for classification, averaging for regression. The purpose is primarily aims to reduce the variance and avoid overfitting by averaging models. So this also will be used for like avoiding all those things. That is all the errors such had occurred in individual models. It will leverage the strengths of different model to improve the generalization. So example for backing technique is random forest algorithm. So here example by combining SVM, decision tree and logistic regression, you can get voting. The next one is boosting. So this is the another example machine learning model. So this will combine multiple weak models, particularly for example decision tree, to create stronger predictive models. So that is for example boosting process. So the key idea in boosting is it will train the model sequentially. So that's very important. So for example, every iteration, so the model will be trained. Okay, so here the models will be trained sequentially with the new model focusing on correcting the errors on the previous one. So that is a concept. So here the core idea of boosting is it will improve the performance by correcting the previous model mistake. Correction can be made by assigning weights. So for assigning weights, we can use AdaBoost algorithm. So for example, for a particular sample or for a particular record, if your model is providing the wrong result, so that record will be provided more weightage. Okay, so the correction can be made by differentiating loss or cost function. That is the concept of gradient boosting, because we are having the different boosting algorithm. If the correction can be made by assigning weights, means that is AdaBoost algorithm. If the correction is made by differentiating loss or cost function, means it is a gradient boost algorithm. The correction can also made by advanced technique that is called as XGBoost algorithm. The boosting techniques will work with different data and same model. So here there are certain steps, that is there are 4 steps to be followed in boosting. So these 4 steps will define the working principle of boosting process. First one is initial model. Initially a weak model will be trained on the entire data set. Then after that weight adjustment. These misclassified or poorly predicted samples from the first model are given more weight. Okay, as I said already, for a particular tuple or for a particular record, if the result is wrong, then that record will be given more weightage. That is called as weight adjustment. Okay, that record is given more concentration. That's the meaning. So weight adjustment. Then after that, sequential training. The new model is trained on this reweighted data and focusing more on difficult samples. Then final predictions. The predictions of all the models are combined and typically using weighted sum or majority voting. So these are the popular algorithms under the boosting: AdaBoost, gradient boost, and XGBoost algorithms. So this diagram shows the process of boosting. We will have a training set. So the training set will be learned by the weak learner. Then after that, testing process will happen. If some false prediction is happened, then automatically the weightage will be changed on that particular record, and that will be given to the new learning algorithm. Again, if it gives false prediction, again some more weight may be increased like that. Again, one more time it will be learned. So finally, we can make a number of predictions. So here, based on the phases, we can get more predictions. Okay, if you make an algorithm to learn multiple times, then you can able to get more accurate predictions. So for example, if you make an algorithm to learn 100 times, then you will get more predictions. Suppose when you make an algorithm to learn 10 times or 50 times, like that. When comparing with learning 10 times and 50 times, an algorithm learns for 100 times, that algorithm will produce more accurate result. So that's the concept of boosting. So the key benefits of boosting is it will reduce bias, and also it will produce strong predictors. So that's all about ensemble learning methods. One is boosting, another one is voting, another one is backing. If you have any doubts or clarification in this, you can ask me. If you have any clarifications, please ask. If you have any classification in, okay, ensample machine learning models, you can ask. I will share all the code and also the problems with you. You can practice after the session. Okay, shall I move to clustering algorithms? If you have no doubt, I can move clustering methods. Any doubts as of now? Okay, thank you. So now let's move to clustering methods. Okay. So first we have to understand what is clustering. That is the task of grouping data points based on the similarity with each other. So we will have different data points. So all those data points will be grouped based on the similarity. So that process is referred as the process of dividing the data points into many clusters. So this grouping process will be particularly done on processed on unlabeled data set. So that is called as what? Clustering. So here we will not have like the final outcome variable. So without having the final outcome variable, we will have some predictions, we will have some outcome. So that is called as what? Clustering. Okay, so in the clustering process, all the data points will be created. That is, the data points will be grouped into different clusters, and every cluster data point will have will have some similarity measures. Okay, so that's very important. For example, whenever we have a cluster, so within the cluster, the data points will have some similarity. So the objects with the possible similarities remain in a group that has less or no similarities with another group. For example, from this diagram, you can understand that clustering process. So here we are giving the raw data with different fruits, but we will not have a label like which is apple and which is strawberry. So like that information will not be available. But based on some similarity measures, it may be a color, it may be a size, or it may be a shape. So based on some parameters, those fruits are grouped together, and this process is called as what? clustering. So here in clustering, we are having two types of clustering methods. One is hard clustering and one is soft clustering. In the hard clustering, the data points will be belonging to only one group. So for example, whenever a data set contains multiple data point, in the hard clustering technique, every data point will be belonging to only one group. A data point will not be belonging to more than one group. So that is called as hard clustering. And in the soft clustering, a data point can belong to another group also. That is, a single data point can be in multiple groups also. Okay, more than one groups also. So that is called as what? Soft clustering. So for example, assume that the data points A, B, C, D. Okay, let's have the difference between hard clustering and the soft clustering. In the hard clustering, assume that there are four data points like A, B, C, D. So here A is belonging to C1, B is belonging to C2, C is belonging to C2, D belongs to C1. So A cannot be in C2, D also cannot be in C2. Okay, a single data point belongs to only one cluster, so that is called as hard clustering. In the soft clustering, so based on the probability value, we will do the clustering process. So here, if we have 50-50 probability, then automatically the data point can be in both clusters. So here, if you take the data point, the probability of the data point to be in cluster 1, 0.91, the probability of the data point A to be in cluster 2 is 0.09. And similar to that, B 0.3 for C1, 0.7 for C2. And for C, 0.17 and 0.83. For D, 10. That is also possible. For example, even you may have 50-50 probability also. 0.5, 0.5 means then automatically that cluster, that is the data point can be in both the clusters. So that is example of soft clustering. Hard clustering means either one cluster. Hard clustering means either in one cluster. Soft clustering means there is possibility of in more than one cluster. That is the concept of soft clustering. Okay. So these are the two types of clustering methods. So now let us discuss some of the applications of clustering. One is market segmentation. So particularly in market, for segmenting the that is for grouping the products or for grouping the customers, we can use. That is for the market segmentation, we can use the clustering. And in statistical data analysis, we can use clustering. In social network analysis, particularly in Facebook and also even in Instagram, and those applications will be using social network analysis by means of clustering. Okay, they can group the customers, like who are all the customers they are, they like this type of movies, this type of post. Okay, if you want to analyze such kind of activities in social network, then we can go for clustering. Even in image segmentation, okay, for segmenting the images, we can use the clustering. For document processing and anomalies detection, we can use clustering. So these are the different application areas in which the clustering technique can be used. Okay, so in the clustering, so for example, whenever we have two data point or two person, for example, person 1, person 2, or the two data points. Data point means set of attributes. So how those data points are closely related, whether the two data points are closely related, or whether the two data points are not closely related with each other. If you want to identify that, we have to use some measures. That measures are referred as what? Similarity measures. Okay, if you want to group here, or if you want to group the two data points, So between the two data points, we have to identify the similarities. If the two data points are having more similarity, then the data points can be grouped together. If the two data points are having very less similarity, they are completely like distanced or completely differed from each other, then the two data points should be grouped in different groups. So to identify that distance, we are using the similarity measure. So normally the clustering process or the clustering will be constructed using similarity or distance. The distance will be also referred as dissimilarity. So here we have to understand one note, that is distance is a way to measure similarity and similarity is a way to measure distance. Okay. So we are doing this process in clustering. There are some of the formulas or some of the techniques which are used for measuring the similarity. One is Euclidean distance, Manhattan distance, cosine similarity, Mahal uh, Lanobis, Mahalanobis distance. So these are the different formulas or different techniques that can be used for measuring the similarity between the two data points. One is Euclidean, Manhattan, cosine similarity, Mahalanobis distance. Okay, these are the widely used similarity measures. Beyond this, some more measures also available. But widely used distance measures are Euclidean, Manhattan, cosine similarity, and Mahalanobis distance. So first, let's discuss the formula for calculating the Euclidean distance between the two data points. So this Euclidean distance is working the principle of Pythagoras theorem. Okay, here we will use the concept of the Pythagoras theorem, and it will signify the shortest distance between the 2 points. This Euclidean distance can be used for data with continuous variables such as height, weight, or age, like that. So whenever we have the continuous attributes, we can go for this Euclidean distance. So the Euclidean distance can be calculated using this formula. Consider a attribute or consider a record with different attributes like P1, P2, Pn, and another record with Q1, Q2, Qn. Assume that these are the two data points. So here we are having the n space. Okay, there are n attributes like P1, P2 up to Pn, and again Q1, Q2 up to Q1. So the distance d can be calculated between P and Q or Q and B using that Pythagorean formula, that is d of P comma Q or d of Q comma B. Both are same, equal to square root of Q1 minus P1 whole square plus Q2 minus P2 whole square plus Q3 minus P3 whole square and Qn minus Pn whole square. That is summation of I to n Qi minus Pi whole square. So this is the formula to calculate the Euclidean distance. Okay. So I will explain with you an example. Okay, when we have the k-means clustering algorithm, this Euclidean distance will be used to calculate the distance between the two data points. We will discuss with an example. So this is the Python code for calculating the Euclidean distance. So here we are importing the math library and we are creating a point with 3 space. Okay, the number of that is n space is equal to 3 space. Here there are 3 attributes like 1, 2, 3, and here we are 4, 5, 6. So this is data point 1 and this is data point 2, and the distance can be calculated using the Euclidean distance function. This is writing separately written here. The definition for this particular function is written here. We are passing the 2 data points. Then after that we are calculating that squared difference. Then after that we will take the square root. So for calculating the square root, we are having that math.sqrt function. Then finally the distance will be returned. So this is the Python code for calculating the Euclidean distance. The formula is given and the code also given. The next one is Manhattan distance. This Manhattan distance is also called as or also known as city block distance or taxi cab distance. So this Manhattan distance is mainly used for discrete variables, particularly it is based on the absolute difference between the 2 data points. Okay, so here we will have the absolute difference. the distance between the two data points will be referred like, will be calculated like L equal to 1 to T. So N in D indicates the number of attributes in that particular data point, XIL minus XJL. So like that we will have. This is representing the absolute difference between those two. So this is the Python code for calculating the Manhattan distance. We are having the two vectors here, 4 space. Okay, in the previous scenario we had 3 space, so here 4 space. There are 4 attributes in the data points. For example, 2, 4, 4, 6. In another data point we will have 5, 5, 7, 8. We will have the absolute difference between the two data points. That is 2 minus 5 and 4 minus 5, 4 minus 7 and 6 minus 8. Sum has to be calculated. So for that we are writing the Manhattan function. The next one is cosine similarity. So whenever we have a high dimensional data, this is very important. Whenever we have a high dimensional data, we can have the cosine similarity. So it is mainly used for text-based data or other high dimensional data. It measures the cosine of angle between the two vectors in a high multi-dimensional space. The cosine similarity will range from -1 to 1, that 1 indicating that the vectors are identical value and 0 indicating that they are perpendicular to each other. Okay, so that is 0. Okay, so the formula for cosine similarity is like A dot B and also like modulus A dot P. That is the cosine similarity, and the formula for this is given here. That is A1 square plus square root of A1 square plus A2 square plus A1 square. So here, this is the observation. Some of the observation can be made from the cosine similarity value. If the cosine similarity is 1, it means that the vectors have same direction and perfectly similar. If the cosine similarity is 0, it means that vectors are perpendicular to each other and have no similarity. If the value is -1, it means that vectors have opposite direction and are perfectly dissimilar. Okay, so like that we will have. The value can be ranged from 0 to 1. For example, 0.5 means some partial similarity. So that values will be representing how much level it is having the similarity. So this is the Python code for calculating the cosine similarity. We are having the two list 534 and 424, and here we are having the dot product of A and B. Then after that we are having the magnitude value. Okay, the magnitude can be calculated using square for all the values. Then after that we have to take the square root. For taking the square root, it is like power of 0.5. Okay, that also can be done, or you can apply method or SQRT function. It is up to you. Then next one is Mahalanobis distance. It is mainly used for calculating the distance between point and a distribution. This is a multivariate distance matrix that measures the distance between point and distribution. If you have such kind of scenario, then only it will be used. So this is extremely useful matrix. Then particularly for multivariant anomaly detection and classifications of high imbalanced data set and one class classification. So here the formula will be d square equal to x minus m power t dot c power minus 1 dot x minus m, and here d is the square of Mahalanobis distance, x is the vector of the observation, and m is the vector of mean values of independent variables, and c power minus 1 will be inverse covariance matrix of independent variable. Okay, so these are the different formulas that can be used for calculating the distance or calculating the similarity among the data points. Particularly in most of the algorithm, we will be using either Euclidean distance or Manhattan distance. Even the cosine similarity will be used very rarely. Most of the clustering techniques will be used either Euclidean distance or Manhattan distance. So first, next we discuss the different types of clustering algorithm. There are number of clustering algorithms are there, like centroid-based clustering or partitioning-based clustering, density-based clustering or model-based clustering, and connectivity based clustering or hierarchical based clustering and distribution based clustering. So like that, there are a number of clustering algorithms are there. So in the partitioning based clustering, we will have like k-means algorithm, PAM algorithm, Clara, FCM like that. But we will discuss only the k-means algorithm. This is most frequently used clustering algorithm in the partitioning based category. In the hierarchical based category, we will have agglomerative algorithm or divisive algorithm or bridge algorithm, ROC algorithm, CURE algorithm like that. But we are going to discuss agglomerative algorithm. The next one is density based algorithm. In the density based algorithm, we will have DB scan, include optics algorithm. We will discuss only DB scan algorithm. And grid based algorithm and model based algorithm we will not cover, but here we will have some grid based algorithm like OptiGrid, click, wave cluster algorithm, and in the model based we will have Gaussian mixture model, GMM algorithm, and class IT and cobweb. So these are some of the algorithms that will come under the category of model based. This is the overview of various clustering algorithms. If you have any doubt as of now, you can ask. In similarity mixers and fundamentals of clustering algorithm, if you have any doubts, you can ask me.
Sir, it's a general doubt. Like, is there any criteria for the data which can be used for these algorithms, or we can use the same data for all different algorithms?
Yes, ma'am. There is no criteria. Actually, whenever we
Yeah,
have the unlabeled data set, that unlabeled
yeah,
data set can be given to any one of the clustering algorithm. So here
okay,
it can be given to either DB scan algorithm, or it can be given to agglomerative clustering algorithm, or it can be given to k-means clustering algorithm. So that like selection of that clustering algorithm may be based on your requirement. In what way you need the output representation? Whether we need in the form of like k-means format, k-means output format, or in the tree structured format, or in like noise point and core point in that form, because every algorithm is producing the output in a small different manner. So based on that requirement, we can choose that algorithm.
okay. The before the procedure will be same for every algorithm, right?
Yes, yes, of course, yes, of
Yeah.
course.
Oh.
And the principle
Ah,
of each algorithm for doing the clustering will be different. For example, in k-means algorithm, the working principle will be different. In hierarchical
okay,
clustering algorithm, the working principle will be different. In DB scan algorithm, working principle will be different.
okay, okay, sir. Thank you.
Okay. Any other doubts? Okay. So first, let's come to that important part, that is clustering. As I told already, in this, we are going to discuss three clustering. One is k-means clustering, another one is agglomerative clustering, another one is DB scan clustering. K-means clustering is a example clustering algorithm for the type of partitioning clustering. Agglomerative clustering algorithm is a example type of algorithm for hierarchical clustering. And DB scan clustering is an example algorithm, clustering algorithm for density based clustering. Okay. In the k-means clustering, the data points will be divided into non-hierarchical groups. So if you want to divide the data into non-hierarchical group, then we can go for this partitioning clustering. This partitioning clustering is based on centroid. Okay, that's why it is also referred as centroid based method. Here in the picture, you can see a diagram. So here the centroid point will be identified. So based on the centroid point, then the data points will be grouped. The data points will be clustered. So between every data point and the centroid, the distance will be calculated. So based on the distance, the data points will be attached with each centroid point. For example, here we are having like red color and green color like that. So the data points which are in the green color are more close to the centroid point in the green color, and red color data points are more close to the centroid point in the red color. So based on that, we are dividing so that it is also referred as centroid based method. It will group the data points based on the closeness. Okay, so here the similarity value will be calculated, that is the distance will be calculated. So if the distance is less, then the data points will be grouped together. So here for calculating the distance, we can mainly use the Euclidean distance or Manhattan distance. So particularly we can use the Euclidean distance algorithm. So here the example algorithm will be the k-means clustering algorithm. In the k-means clustering algorithm, the data set will be divided into set of k clusters. That is very important. If you give the k value, so if k value is 5, 5 clusters will be there. If k value is 2, 2 clusters will be there. If k value is n clusters will be there. So here the data set is divided into set of k clusters, where k is used to define the number of predefined groups. The cluster center is created in such a way that the distance between the data points of one cluster is minimum as compared to another cluster centroid. So that is very, very important. As I said already, the red color point is not close to the yellow color centroid or green color centroid. Red color data point is close to the red color centroid point. So that's why we are forming that clusters. So as I said already, the k-means clustering algorithm is an unsupervised learning algorithm because it will learn the data, or it will learn the information from unlabeled data set. So the k-means clustering algorithm will group the unlabeled data set into different clusters. So here k is the number of predefined clusters that need to be created. So this k-means clustering algorithm is an iterative algorithm. So that divides unlabeled data set into k different clusters in such a way that each data item belongs to only one group that has similar properties. Okay, so here the k-means clustering algorithm is a type of hard clustering, so that one data item will be belonging to only one group, and also here one cluster, at least one cluster must have at least one data point. So in the k-means clustering algorithm, the two tasks will be performed. The two major tasks will be performed. First one is determine the best k value. Okay, so determine the best k center points or centroids by an iterative process. So assign each data point to, the second step is assign each data points to its closest k center. Those data points which are near to the particular k center will create a cluster. So here the rules will be each group contains at least one object, and each object must belong to exactly one group. So this is these are the rules that will be followed in k-means clustering algorithm. So these are the different steps, detailed steps that will be followed in k-means clustering algorithm. The first step will be select the number k to decide number of clusters. So here, whenever we have a data set, first we have to identify how many number of clusters to be created. So that is very, very important. So for example, if there are 10 data points, whether the 10 data points should be divided into 3, or whether the 10 data points should be divided into 4, or whether the 10 data points should be divided into 2. So like that, select the number k to decide the number of clusters. Then second step will be select random k data points or centroids. So after selecting the clusters, randomly select the data points as the centroid. Okay, we have to select the centroid point. Then that for selecting the centroid point, we can choose the random procedure. Okay, randomly we can select the k data points as centroid point. Then after that, assign each data point to the closest centroid, which will form the predefined cluster. So now we have to calculate the Euclidean distance between the data point and the centroid point. So you have to choose a data point. Then you have to identify the data point is close to which cluster. That has to be identified. So in that particular cluster, the data point has to be added. Then calculate the variance and place a new centroid of each cluster. Again, after that, you have to perform the variance and place a new centroid of each cluster. Then repeat the third step, which means reassign each data point to the new closest centroid of each cluster. Once that new centroid has been calculated, again we have to calculate the new centroid point under the other data points in the cluster. Then if anything has to be changed, that has to be done. If any reassignment occurs, then again go to step 4, else we have to finish. So now I told that whenever we have the different data points, we have to choose the k value. Okay, k value means the number of clusters to be created. That may be 2 or that may be 5 or that may be 10. So how to choose the k value? That is very important. Okay, either you can choose the k value randomly. Suppose while choosing the k value randomly, that may not be correct. That may not be an optimized k value. So that in order to choose the correct k value, we can use a method. That method is called as elbow method. Okay, we can use a method. That method is called as what? Elbow method. Elbow method will calculate or will work based on WCSS value. WCSS means within cluster sum of square. That value will be calculated. So based on that, the k value will be selected. The formula for calculating the WCSS will be sum of PI in cluster 1, that is distance between PI and C1 whole square, plus again PI in cluster 2. So like that, for every data point we have to calculate sum of, that is within cluster sum of square. Okay, so the value will be this sum of square of the distance between each data point and its centroid within cluster 1, and the same for other two terms. To measure the distance between the data points and the centroid, we can use the method Euclidean distance or Manhattan distance, as I said already. Okay. To find the optimal value of clusters, it executes the k-means clustering on a given data set for different k values, ranges from 1 to 10. So for each k value, calculate the WCS value, plots a curve between the calculated WCS value and the number of clusters. There will be a sharp point of bend, or a point of the plot looks like an arm. Then that point will be considered as the best k value. For example, like this. For number of, when you consider cluster 1, what is the WCSS value? Cluster 2, what is the WCSS value? Cluster 3, WCSS value. Cluster 4, WCSS value. Like that, we have to calculate the WCSS value when you have the different number of clusters. Then at a particular moment, you can find a bend. Okay, direct bend. So that bend value will be the best optimal k value. So based on that, you can identify. So that is the best k value. So now let us have an example problem for k-means clustering algorithm. So please wait for a minute. Okay, thank you. Okay, so now let us consider a problem using k-means clustering. Assume that we have a data set, like the data set is having the two attributes. One is x1 and x2. There are 6 data points. Assume that a1, a2, a3, a4, a5, and a6. Assume that these are the data points, and there are 2 attributes in each data point. For example, x1, x2. Even you can have x3, x4, like that. Even n attributes you can have in a single data point. So x1, x2, x3, x4, like that. But here we are having only x1, x2. A1 is having 1, 1. A2 is having 2, 1. A3 is having 2, 3. A4 is having 3, 2. A4 is having 4, 5, 4, 3. A6 is having 5, 5, like that. Okay. So first, let us follow the steps of k-means clustering algorithm. The first step is we have to choose number of clusters. That is, we have to choose the k value. For choosing the k value, as I said already, either you can choose the random k value or you can choose the elbow method. You can apply the elbow method, and in the elbow method, we have to calculate WCSS value, and you have to plot this WCSS value wherever you are getting the bend in that particular graph, so that respective k value can be the optimum k value, or otherwise you can choose randomly. So here I am having k value as 2. This k value cannot be an optimal value, but here we need 2 clusters. That's all. Okay, my expectation is 2 cluster, so that I am giving k value is 2. Even if you want to give 3, yes, of course you can give 3. It's up to you. I am giving k value as 2. This, then after selecting the 2 k values, then we have to choose the centroid. Okay, we have to choose the center point for these 2 clusters, so that we can choose random to initial cluster centers. Okay, so for choosing the k value only, we have to choose elbow method. After choosing the k value, then we have to select respective center for each cluster. That center, initial center point, initial centroid can be any data point. Okay, so for example, assume that we are having v1, so that is cluster 1 center point, that is 2, 1, that is a2 I have taken. And for center head v2, that is 2, 3. For example, a3 I am taking. Okay, so we are choosing random to initial cluster center. Example, v1 equal to 2, 1, v2 equal to 2, 3. Then after that, find the distance between cluster center and the data points. Okay, now what we have to do, for all the data points, there are 6 data points. A1 is 1, 1. A2 is 2, 1. A3 is 2, 3. A4 is 3, 2. A5 is 4, 3. A6 is 5, 5. And the cluster center is v1 2, 1, v2 2, 3. So between this center and the data points, we have to calculate the distance, or we have to calculate the similarity. I told that similarity is a way to calculate distance. Distance is a way to calculate the similarity. Okay, so here what we are using, we are having the Euclidean distance. So Euclidean distance will be d equal to x1 minus y1 whole square plus x2 minus y2 whole square. So like that. Okay, since we are having only 2 attributes, x1 minus y1 and x2 minus y2. Similar to that, if you have 3, x3 minus y3. If you have 4, x4 minus y4. That also can be added here. So here, okay, assume that this is the center head. Okay, v1 2, 1 formula is given, and data point like 1, 1, a1. So x1 is 1, x2 is what? 1. Y1 is 2, y2 is what? 1. So now the formula will be x1 minus y1 whole square. That is 1 minus 2 whole square plus 1 minus 1 whole square. So we have to calculate root of 1. The value will be 1. So like that, For everything, we have to calculate. That is between 1, 1 and 2, 1. Between 2, 1 and 2, 1. Between 2, 1, 2, 1, the value will be what? 0. 2, 3, 2, 1, 3, 2 and 2, 1, 4, 3 and 2, 1, 5, 5 and 2, 1. The distance has to be calculated. And again, this is the another cluster center. Okay, so now we have to calculate. So now here assume that A1 is having distance 1 between this first cluster and 2.24 between this cluster center. Which one is the minimum? 1 is the minimum, so that A will be added in cluster 1. Is it clear? Since A1 is having the minimum value between cluster 1, A1 will be added in cluster 1. Okay, if you compare the distance between A1 and cluster 1 and cluster 2, A1 and cluster 1 is having 1, A1 and cluster 2 is having 2.24, so that A1 and cluster 1 is minimum, so that A1 will be added in V1. Then A2 and V1 0, A2 and V2 2, the minimum one is 0, so that it will be added in V1. Then for A3 and V1 2, A3 and V2 0, so that it will be added, A3 will be added in V2. And A4 and V1 is 1.41, A4 and V2 also 1.41. Now there is a tie between the two cluster distance. Is it clear? Tie between the two cluster distance, so that you can choose any one, either V1 or V2 you can choose. Assume that I am choosing V1. Okay, even V2 also possible, it's up to you. Suppose the distance is same for the two cluster center for a single data point. That data point can be added in either first cluster or either with second cluster. So assume that we are using V1. Then between A5 and V1, 2.83, A5 and V2, 2, so that A5 will be added with V2. And A6, V1 5, A6 and V2 3.61, so that A6 will be added with V2. So this is a like intermediate cluster assignment. This is not the final cluster assignment. This is an intermediate cluster assignment. Now what we have to do? So here in V1, there are 3 data points, A1, A2, A4. In V2, there are 3 data points. So for example, A3, A5 and A6. Now we have to calculate the cluster center, recalculate the cluster center. This is very important. That is a step 5. What we are doing? We are taking the average value. What is a A1 value? 1, 1, A2 value 2, 1, A4 value 3, 2. We have to add it. 1 plus 2 plus 3, 6. 1 plus 1 plus 2, 4. So 1 divided by 3, there are 3 data points. So 1 divided by 3, 6, 4. So if you calculate it, 2, 1.3. So this is the new cluster center for V1. Then similar to that for V2, we have to calculate. For V2 also there are 3 data points, so that 1 divided by 3. Then A3 value 2, 3. A5 value 4, 3. A6 value 5, 5. We have to add the respective attributes 2, 4, 2 plus 4 plus 5 and 3 plus 3 plus 5, so that we will have 11. Center head will be 3.67, 3.67. Now what we have to do? Repeat the steps from step 3. That is the new distance, that is new center head will be 2, 1.3. And for V1, new center head for V2 will be 3.67 for V2. Now what we have to do? We have to calculate. We are taking all the data points and we have to calculate the distance between the data point and the new center head. Now between 1, 1 and 2, 1.3, we have to calculate the distance. Between 2, 1 like and 2, 1.3, we have to calculate the distance. So now we have calculated the distance. So here 1.05, 3.78. So here V1 is having less distance, so that A1 will be added in V1. So now what is it? Here 0.33 V1. Here 1.67 V1. Here also V1. So this will be V2, V2. Now what happened? The clusters have been changed. Is it clear? So now in V1, we are having A1, A2, A3, A4. In V2, A5, A6. Again, what we have to do? We have to calculate the cluster center. Since there are 4 data points in V1, here we will get 1.4 and we have to add it 1, 1 plus 2, 1 plus 2, 3 plus 3, 2. And we have to calculate it 1, 4 of 8, 7. We will have 2, 1.75. Then after that in V2, there are only 2 points, so that 1 divided by 2. The data points for A5, 4, 3, and the data points for A6, 5, 5. So when you add it, 4 plus 5, 9, 3 plus 5, 8, 1 divided by 2, so 4.5, 4. So the cluster center for V1 will be 2, 1.75, and for V2 will be 4.5, 4. Okay. So now again we have to calculate, okay, the distance table. So here the center will be like this, center will be like this. So now we are assigning the cluster based on the small value. Okay, so here 1.25 or 4.61 V1. Here 0.75, 3.9 V1. 1.25, 2.69 V1. So 1.03, 2.5, the V1 is smallest value, so that V1 here. So now we are having again V1, A1, A2, A3, A4, V2, A5, A6. So now between the previous iteration and this iteration, there is no change in the cluster data points. Hence, there is no change in the cluster data points. So we can stop the procedure. So we have asked the k-means algorithm to create 2 clusters. One is V1 and V2. In V1, we will have A1, A2, A3, A4. In V2, we will have A5 and A6. So this is the k-means clustering algorithm. So this is a solved example. If you have doubt in this, you can ask me. If you have any doubt. Thank you, sir. Any others? If you have any clarification in this, you can ask. It's very simple. First, we are taking the data point, and initially we are choosing the k value. The k value may be randomly you can select. Okay, or you can apply the elbow method. So if you want to elbow method, if you want to apply the elbow method, yes, of course, you can get the best k value. Otherwise, you can choose it randomly. It is up to you. Suppose I need 5 clusters. Okay, you can give 5 clusters. It's up to you. Then after that, you can choose the center points, centroid points randomly. That's up to you. Okay, there is no method for selecting it. Randomly, you can choose it because that random centroid value will be recalculated again and again. The perfect centroid point will be calculated later. In the forthcoming iterations, it will be calculated. Then after that, we are calculating the distance. For calculating the distance only, we are having that Euclidean distance. So, when a data point is having minimal distance with a particular centroid, then that cluster, the data point will be added in that particular cluster. So like that we are doing. Then after that, again, we are calculating the centroid by calculating that average. Then again, we are calculating the distance. Then we are checking that whether the data point is belonging to the same cluster or not. Suppose if it is getting changed, sometimes during the second iteration or third iteration, the data point may be moving from one cluster to another cluster. That is also possible. Okay. So now, again, we are doing the iterative process. So while doing this process again and again, in some situation, what will happen? The cluster data points will not be changed in the current iteration with the previous iteration. If you compare the current iteration and previous iteration, the data points will not have any change. All the data points will remain in same cluster. Okay, when comparing with previous cluster. Suppose if you got that moment, then you can stop your iteration. Then that will be the final cluster, and that will be the final cluster data points. Any doubt? Okay, so here this is the coding, Python coding. Okay, so the Python coding is very simple. So here, as I said already, we are not writing the code for machine learning algorithm. It is already there. Okay, we are having the k-means algorithm. So here, simply we are giving the data point. So in sklearn library, in sklearn.cluster module, we are having a k-means algorithm, so that we are importing that library. Okay, we are importing that module. And matplotlib byplot, we all know that that is for generating the graph. If you want to represent the data points in the two-dimensional representation, the graphical representation, then only you need what? Matplotlib.byplot. Otherwise, it is not necessary. Then from sklearn.cluster import k-means. So this is for importing the k-means algorithm. So here we are generating the data points, x value and y value. So even you can have like z value also. It is up to you. Okay, x, y, z. Even one more, it is based on the dimensions. Okay, it is a two-dimension. Even if you want to have 3 attributes, that is also possible. 4 attributes, that is also possible. 5 attributes, that is also possible. Since it is a two-dimension, we are having this graph. Okay, it can have 3-dimension also, x, y, z. It can have 4-dimension also. It's very simple. The respective dimensions should be taken, and the Euclidean distance has to be calculated. That's why I have given formula for n-dimensional space formula for Euclidean distance, like x1 minus y1 and x2 minus y2, x3 minus y3, like that. Then we are having a list by combining these two separate lists. We are using the zip function. This will combine the two separate lists into a like a data frame, like that. Then after that, we are printing it. Simply, we are applying the k-means clustering. Why applying this is a predefined function. Okay, k-means is the predefined function. So simply we are applying that k-means clustering, and we are specifying how many number of clusters. If you give two clusters will be created. If you give three clusters will be created. Then after that, we are applying k-means.fit.data. So this will generate that graph, and we are plotting that scatter plot, and we are displaying that graph. This is the k-means, that is Python code for k-means clustering algorithm. This is the another problem. Another example problem. Even if you want to solve it, you can have it. So consider the following 8 points with the x and y representing locations into 3 clusters: A1, A2, A3, A4, A5, A6, A7, and A8. And they have given 3 cluster center. Okay, so here you no need to randomly select the cluster centered points. In the problem itself, they have given there are 3 clusters. Like the 3 cluster centroid point will be, one is A1, another one is A4, another one is A7. So from this, you can clearly understand that the k value will be 3. You no need to select the random k value. The k value also fixed. The k value will be 3. And also for each cluster, the centroid also given. No need to select the random centroid point. So, and also the distance can be calculated using Manhattan distance formula. That is x2 minus, that is absolute value we are taking. We are not using the like Euclidean distance. Euclidean distance means square root of and square of difference between the two data points. But here they are taking that absolute value, more or less same. You will get a same value for both. Okay, so here we have to use the k-means clustering algorithm to find 3 cluster centers after the second iteration. Okay, they are asking to stop you up to second iteration. Okay, no need to proceed until the end. You can stop at the second iteration, then you can identify the 3 clusters with respective data points and also centroid points. And this is the another problem. Use k-means algorithm to create 2 clusters. There are 5 points that are represented like this. It's up to you. The problem may be given in different way, like this. Any doubt as of now? If you have any doubt in this portion, you can ask me. Next, we will have hierarchical clustering algorithm. Hierarchical clustering algorithm will be explained in afternoon session. So now the morning session is going to be over. If you have any doubt in this portion, you can ask me. The hierarchical clustering and density-based clustering. we will discuss, and also what are the measures or what are the metrics that are used for evaluating the clustering algorithm will be discussed. Okay, for example, if you have regression algorithm, the regression algorithm will be evaluated using mean square error, root mean square error, mean absolute error, and R2 score. So like that, we are having the different metrics to evaluate the regression algorithm. And to evaluate the classification algorithm, we all know that accuracy is there. That is confusion matrix we are generating. So from the confusion matrix, we will have some metrics like accuracy, precision, recall, F1 score, and ROC curve. So like that, number of metrics will be there. So based on those metrics, we will be evaluating the classification algorithm. Similar to that, the clustering algorithm can be measured using some measures, some metrics. We will discuss about that too also in the afternoon session. Yeah, sensitivity, specificity. So these are the some of the metrics will be used for evaluating the classification algorithms. So all those metrics will be identified from confusion matrix. We all know that like true positive, true negative, false positive, and false negative. So based on that, we can calculate all those things. So like that, there are some of the measures will be there for clustering, for evaluating the clustering algorithm, whether the clustering algorithm is working well or not, whether it is working correctly or not. If you want to, because whenever you have an algorithm, it has to be evaluated, is it right? So for the evaluation, we will have some assess. We will discuss about that in afternoon. As of now, if you have any doubt, like even if you have doubt in fundamentals of machine learning, or particularly in unsupervised learning, or even if you have any doubt in supervised learning, also you can ask. And if you have doubt in ensample machine learning methods, or if you have doubts in similarity measures, and the k-means clustering algorithm, if you have any clarification in this portion, you can ask me now.
Thank you, sir. Thank you so much for your wonderful session, sir. It was very great session, sir.
Okay, thank you so much for your patient listening. Again, we will meet at 2 o'clock. Thank you all.
Thank you all. Thank you, Suresh, sir. We will be joining the afternoon section by 2 p.m. sir. Thank you all.